Okay, we're going to be looking again at Venn diagrams. For some reason, my background has turned crazy colour. Okay, so let us have a look at what this means. So the complement of a set is, get my right colour up. So we're going to look at what's something called a complement of a set A. And it's all those elements which are not, complement set is members which are not members of A are called the complement, and we call it A dash. So that might be clear as mud, so I'll show you what I mean. So let's draw our universal set, and within our universal set we're going to have set A and we're going to have set B. So everything in here is a member of set A. So we're now going to think, what are the complement? So we're going to look at the complement A dash of set A. So we said the things that are in the members of the complement of set A are those members which are not members of A. So we're going to shade in those members that are not in set A. So there's set A. So everything in the background is going to be in the complement, and everything in set B that doesn't overlap into A. So this whole yellow section is now get my blue back from the pen. So everything in this yellow section, the yellow section is set A dash. That wee dash means the complement. So let's look at some examples to help us with this a bit further. So we're going to have another diagram. Get the rectangle, and we're going to have set A, and we're going to have set B. I'm going to close that up a bit more so we don't. We're going to do some shading in a minute. So we want to do two copies. One is going to be, we want to do set A dash intersection B dash. Now we're going to, and we also want to do over here, we'll do it over here, we want to do A intersection B and the complementary set. So how are these different? That is the question. What makes these two things different, apart from the fact one's got brackets and the other one doesn't? So let's explain what makes them different. So let's draw the two universal sets, and we'll start off with what we've got up the top. We've got A, and we've got B, and we've got A, and we've got B. Now with this one, we need to be really careful with where the brackets are and where the wee dash is denoting the complementary set. So this means A dash, that means everything that is not in A. And this means everything that's not in B and their intersection. So that basically means, get a different colour, everything in the background. So it's not in A, it's not in B, it's everything in the background. Now this one is a bit different. A intersection B is where the A and the B meet. It's this wee bit in here. But they want the complementary set of A intersection B. So it's everything that's not in this little bit in the middle. So it's going to be everything in the background, everything that's in A, but not in this bit in the middle, and everything that's in B, but not in this place where they intersect. So it's this wee bit here is not included in the complementary set that we're talking about. Let's look at another example. So I'll get my blue pen back. So we're going to look at a diagram. The diagram shows sets A, B, and C. Shade the region. I would also just put a wee practical point in here. In the exam, bring a coloured pencil. Shade the region corresponding to A dash, complementary set of A, in union with B, intersect, not in union with, sorry, intersection, it means intersection, not in union with, C. So let's see what our diagram actually looks like. So we've got our universal set, and now we're going to have A, and we've got a big bin B, and then we've got C. So first, shade the complementary part of A. So we're going to change our colour. Oh dear, let's undo that. Yes, I'll do. So we want to firstly shade the complementary part of A. So that's everything that's not in A. So it's the background, and it's going to be what's in B, but not in the bit that overlaps. This bit here that's between B and C, and everything that's in C. So everything that's not in A gets shaded because it's A, the complementary set of A. Now, B I have noticed a typing error in the Edexcel book. The question posed has an intersection, but the solution has union. So let's change the question to what the actual solution is given. Let's rub this bit out here. and we will change the question. Oh, so this is the solution that the book gives is for this, not the one previously. So let's now draw the sets again. I'm going to run out of room with, let's get a view. So we've got A. So this one here is A dash. And then we've got B. And we've got C. And what we're going to do now is B in union with C. So we're going to colour in everything that is in B. So everything that's in B, oh no, let's undo that one, that's in A. And everything that's in C. So it's going to be, oh, not that one, this is coloured in everything. Nope, that's coloured in the wrong bits too. That's the wrong bit too. Basically we want to, I'll just do it with the pen. It's going to be easier. So this bit here, this little bit in here, and this bit here is also going to be B in union with C. So now we want to find the last bit that we want. I'm going to have to do it over here. Oops, the daisy, that's the wrong thing. There we go. And change my colour back, otherwise we're going to have, oh, wrong thing. I want to get the pen back, I want to get rid of the rectangles. So we want set A again, and we want set B again, and we want set C again. And so we want to find the complementary set of A intersecting with B union C. Take the intersection between these two diagrams. So that would be, I've lost, so we need to, I've not, that's lost its colouring in, but there and there. So that's going to leave us with this part, and this part as the union between where A intersection B. So if we look here, we've got in the complementary set of A, everything in the background is coloured in, and everything in B is coloured in, and everything in C is coloured in. And in this one, everything in B is coloured in, everything in C is coloured in, but this bit here where it goes into A is also coloured in, but here the bit between A and B and C is not coloured in. So you're looking for this one, what regions are all coloured in at the same time. So this, which is, it gives us this part here and this part here, but not the stuff that's in A. So that's why A complementary set of A in intersection between the set of B in union with C is this. That's quite complicated, and I hope it makes sense. Let's try another example, because this is quite challenging. it's easy to get yourself in a bit of a muddle. So we're going to again go for the E is going to be the positive integers less than 20. A is 3, 6, 9, 12. B is 5, 10, 15. So let's illustrate these sets with, and we've got C as well. C is 6, 12 and 18. So let's illustrate the sets with a Venn diagram. So let's begin with just putting in A and B. So A is 3, 6, 9 and 12, and B is 5, 10 and 15. There's no overlap. So A is going to be over here and B is going to be over here. They've got nothing in common. C has 6, which is also an A, and 12, which is also an A, and 18, which is in neither A nor B. So C will be here. And so that's nice and simple. So for when you're having to draw more than one set on a Venn diagram, start off with put them in one at a time. So we did one A and B, and then we brought in C, and so that makes it a bit simpler than trying to do them all at once. So I hope that helps.